It was a beautiful October on the Colorado School of Mines campus. And then all of a sudden, disaster strikes. This thief is stealing somebody's bike and riding away with it. And here I have the anti-bike theft device. As you can see, we have LEDs that will light up when the sensors inside are triggered, and we also have holes that will amplify the sound of our speaker inside. And these two sensors, our vibration sensor and our flex sensor, will run to different locations on the bicycle and trigger different things. And inside of here we have an accelerometer that will sense motion. Here we have taken off our wooden casing to show you the inside of our device. First, we have our accelerometer. When the board accelerates up or down, right or left, or forward or backward, the accelerometer will read the acceleration, and the voltage that it reads will cause the orange LED to turn on. Next, we have our flex sensor, which will go near the brake of the bike. When it bends like this, it will create a variable resistance, and this variable resistance will create a variable voltage. And this voltage will turn on the blue LED that we see here. And our final sensor is our vibration sensor. When it moves like this, it too will create a voltage that will cause this yellow LED to turn on. Each sensor has their own LED, but there's only one speaker. So whenever one of the sensors is tripped or triggered, the speaker will turn on to sound the alarm that the bike is being stolen. So this is the inside of our device. So now I'm going to demonstrate what the sensor does. So when we blend the vibration sensor, we can see the yellow LED going on and off, and we can hear the speaker making noise. And then when we move the board up and down, we can see now that the orange LED connected to the accelerometer goes off. And here we have our flex sensor. When it is bent, it lights up the blue light.
So here we have our real-time plots for all three of our sensors, the accelerometer, the flex sensor, and the vibration sensor. This is the voltage reading from the accelerometer, and as you can see, the voltage is always going up and down in it, but we have it calibrated so if it goes over 1.3 or below 1.3 or 0.3 volts, it will trigger both the speaker and the LED. Next we have the voltage reading for our flex sensor, which, as you can see, it didn't do a whole lot, but once it gets triggered, it sounds speaker and the LED. And finally, we have the plot for our vibration sensor, which goes off frequently and also sends the alarm once it's triggered at all. So here's our text file, which shows all the voltage from our various sensors, and it gives us the real-time voltage readings from the accelerometer, the flex sensor, and the vibration sensor for the whole duration of the run, which is for 30 seconds in our case. And it will trigger the LEDs and speakers whenever it goes over the voltage which we calibrated it for.
Device actually on the bike. As you can see, it is attached to the front of the bike, and the vibration sensor runs along down the side and is next to the wheel, so that when the wheel turns, it will hit the vibration sensor, which will trigger the LEDs, which you can see here. And then on the brake, we have the flex sensor, so that when the brake is pulled, it will bend the flex sensor and cause another LED to go off. And when the bike moves, it will activate the accelerometer, which is inside. Now let's see the device in action. Here comes the thief.